Hi everyone, in this video I want to build a password manager. That is a program which saves on a file all the password of different websites, but I want them to be protected from an external user which want to look at them. We will implement this in Python. To be fair, some of the program has already been written because I want to focus on the cryptographic part. So let's see what we have. You can see that I have three different commands. I can read a password that has been written. I can write a new username password pair, and I can exit from the program. For example, I start by writing a new user account credential. Again, another user account. And now let's try to read it. The problem is that on the file, those passwords are stored in clear. The library we will use to implement the cryptography is PyNICL. This is the official documentation, and we look for secret key encryption, that is encrypting and decrypting with the same password. So first of all, we can see that we have to instantiate a secret box. That object will let us to encrypt and decrypt any message that we want. In particular, a secret box takes as input a key. Pay attention that a key is different from a password. The user will know its password, that is a sentence. On the other end, a key has to be 32 bytes long. We have to instantiate a secret box object. We instantiate it before the main loop. We can see that we have to import an ACL. And before importing it, we have to install the library. We simply run pip install and PyNICL, which is the name of the library. We can see that the error message goes away. And we assume that the key is passed from the outside. We will see after how to implement it. Now the user inserts the password you want to store on the file. Before appending it to the user's list, we have to encrypt it. To encrypt it, we follow the documentation, and we can see that we can use box.encrypt. The message we want to encrypt is the password that was passed by the user, and we rename the variable into encpass with WE. Okay, pay attention that all the strings that we use inside an ACL are encoded. There is that B in front of the name. We have to call the function encode on the string. And for example, we pass UTF-8, which is a standard encoding. But we have to ask the user for that key. So let's assume that there is a function read key or read password. We pass the key and then we implement the function. Now we have to generate the key from the password. To do this, we have to use a key derivation function. We can also find it in the documentation. And we start copying the first instructions. Let's import, we add the namespace and we import all the library we need. We can see that for the key derivation function, we also need a random value, default. The fact is that we cannot generate a new salt every time we start the program. The salt is generated the first time, and then for the same password remains always the same. So the only way we can achieve this is to save the salt on a file. Pay attention, it's not a problem if the user reads it. So we start a new Python script which only saves this random value on the file, and then we will read it. We start a new script. And we copy inside the salt generation, which is only a random number of the correct size. And then we save it on a file that we call salt. This salt is a binary object, is not a text object, and so we have to decide how to save it. For example, we could save it X representation. That is, we read it as an hexadecimal number. Let's run it. Oh well, I want it to run init.py. Okay, we can see that we created the salt. Now, instead of generating a new random number, we read the one from the file. We have to read the hexadecimal form and build a bytes object. Now we can ask the user for the password. In particular, we can import the library getPass, which offers the method getPass, which is like input, but the password is hidden. And finally, we can generate the key from the password. Looking at the documentation, we have always to write an ACL in front if we don't import the single secret pw hash, etc. And we return the key. Now, the salt file could not exist, but in that case, the program cannot go on, because to decrypt any message, we need it. If we lose the salt file, we can't decrypt the data anymore. And so the program has to finish. Let's try. In this case, we can see that the password is visible, but it's only because we are in a debug environment. Okay, there is a problem. Let's see. In the key derivation function. Okay, pay attention, all the strings are always encoded, and so we have to encode after having read it. Let's try again. Okay, let's try to write a new user. Always the same. Password. And let's see the content of the file. We should have deleted the old file. We haven't, so the first two are the entries that we entered before. I don't like that the string was serialized by Python. This is really difficult to read, so we have to encode ourselves. For example, as a binary data, we could also encode it as an hexadecimal in its hexadecimal form. Let's delete the old file and we try again. We insert the password and we create a new entry. We can see that robot and example.com are still in clear, but the password is now encrypted. To be able to read it, we have to decrypt it. So we move to the read command, and when we output it, instead of giving it immediately in output, we have to call the function decrypt. Let's try to run it. Okay, take password. Let's try to read password. Okay, that's right, the user.password is an hexadecimal value. We have to read it. Let's try to run it again. Okay, again, this is an encoded string, so we have to decode it. Let's try one more time. That's it. We can see that on the file the password is encrypted, but when we read it, it isn't clear.